Yes, I think I'm recording, correct?
Yes.
All right. So this is particularly the basic instrumentation system. Okay. 1, 2, 3, 4. 4 blocks. Basically, the first one is the sensor. Then we have signal conditioner. Then we have A to D, and we have previously covered micro P and micro C. For the sensor and signal conditioner, all right, you may have seen in the previous lectures when we discussed about this undergraduate lectures where we make all the revision and all that. You may have seen lecture 5 to lecture 7, 5 to 7. Then you have 8 to 12 from this part. All right, which we have covered. All right. So previously in the last last week we have covered this topic. All right, as isolated box basically. Okay. So this is I would say the position of the knowledge that you may have seen or you may have covered in the previous topics. For any basic system of instrumentation, this is the blocks. All right. So this is basically what you have seen. All right. So last week we are looking at the end part, which is the display part, which is the processing part, which is behind this last box number 4. We usually will have the micro P and micro C. All right. So we have seen the basic building blocks of any micro P system, any micro C system. Seen how the data is being given to these processing elements. Which is 0, 1, 1. Right. So from here onward, you are working with digital system. But from here onward, all are in analog form. So here we are talking about voltage. We are talking about current. We are talking about impedance. How do I go through here? We're talking about impedance. I hope you can read my artwork here. Okay, so this is basically you know, things that goes into A to D are basically reside in the analog world. Of course, things after A to D is basically all digital. Okay. Okay. So what we are looking tonight is basically how the information from analog world is moving towards I would say moving towards digital world basically. So this is the chapter that we are going to see through the data acquisition and interfacing system. Basically, is data that transfer from analog world to the digital world, from voltage, current, and impedance, moving towards 0, 1, 0, 1, 0, 1, and this is also meant by the data interfacing. All right. So they say here that acquisition system consists of many components integrated. So if you look at the data acquisition system, we are still basically, you have 1, 2, 3, 4 points. Basically, this thing 1, 2, 3, 4 still map the previous block that we are talking about previously. The first one is, the transducer. The second one is signal conditioner. The third one is convert to digital. The last one is process and analyze. So this thing basically representing by this 1, 2, 3, and 4. All right. So basic system of instrumentation basically can be represented by easily by any data acquisition system. All right. As you may have seen from the from this slide, data acquisition system will be having this thing. Data acquisition can be also taking a form of basic system of instrumentation. Okay. Oh, how do I slide this thing? Oh my god. Oh, I have, yeah. Okay. So this is what we have previously. Sorry, guys. So this is the flow of information. What do I have here basically? Sorry. I'm browsing through the things. So I have that. So again, as you can see from the slides, the block diagram of typical data acquisition system, basically it will very similar, and it goes back to the system of instrumentation, as you can see from previous slide, from the diagram that I have mentioned just now. Okay, you still have this sensors part over here. You still have the signal conditioner, you still have the A2D and the computer part. Of course, as I mentioned previously, from here onward, these are all analog, and from here onward, these are digital. All right. So you may have a physical system, transducer, and sensors are basically the elements gather the data, sensing the data environment. Right? We have this from lecture 8 to 12, I think. We have capacitive, we have inductive, we have accelerometer, and many others. And then the signal conditioning part, where signal are basically and some of them are being matched, converted and all that. All right. Then you have A2D, which receive analog signal and convert into digital representation by 010. This is basically, if you are talking about any kind of DAQ system, you are basically describing this block diagram system. All right. So I don't have to go through this. I think we have go through this thing several times. Okay, the transducers, as we have go through this. I think we have go through this. The sensor part. We have temperature, pressure, light. Many others. All right, you don't have to go through this. Signal conditioner also you may have seen from our presentation. All right, you will find amplification. You have a lot of I would say matching circuit. You have filtering, you have Wheatstone bridge, if you still remember. Okay. All right. So okay. So this the block diagram that you may have seen here is I would say is a very basic DAQ system. From one direction flow from left to right. Okay, you have one sensor. Okay, you have one signal conditioner, you have one A2D, and you have of course, computer at the end. All right. But if you are looking at this diagram, in some system, because previously you are looking at one sensor, and you use one sensor, you connect to one signal conditioner, and then you connect to one A to D, and you get one reading at the output. All right, you are looking at this throughout all the lectures that you may have seen previously. All right, one sensor, one output, one sensor, one output. All right, one instrumentation system, one sensor, one output. All right. So in this slide, you are looking at multiple sensors. One, two, maybe a number of sensors, and of course, for that particular sensor, you have to connect to a specific signal conditioning system, and then you may have you can have up to thousands of sensors. You can have up to 1,000 of conditioning box, and this is the digital DAC board. Okay, and then it goes to the computers. All right. So this is some kind of data integrator where you have a signal from sensors, from multiple sensors. All right. Okay. This is the A diagram. If you look at the B diagram, you have multiple analog inputs. All right. Then you have this. Then you have, of course, amplifier, ADC, and many others. All right. So DAQ basically, you have to understand that the DAQ basically representing any system of instrumentation. You understand it correct? You always look at one sensor, one system instrumentation, one output. Okay. You may be looking for something like this or like this, in which you have multiple sensors going to one DAQ. All right. If this happens, you basically need to you probably need to work with so that the system can basically receive or connect input from multiple sensors. All right. So
Excuse me, doctor.
yes, please. Thank you.
Should we sketch this circuit or just understand it or what?
Basically, all right. You basically have to understand it. I don't know if you need to sketch it, but of course, thank you very much for the basically of you need, if you speak about any basic system of instrumentation, if you speak about any system of EQ, you are looking at this box.
Yes.
From left to right. You can just draw it in your mind. Basically, you have to always remember basic system of instrumentation, basic data acquisition. You always talk about this with 4 blocks. That's all.
Okay.
Yes. So all that I'm saying is that previously, these 4 blocks are, I would say, these 4, okay, in which 1, 2, and 4, you have seen it. You have covered in the previous sections. All right. So if I were to ask you about sensors, you know what sensors you should be talking about. If I were to ask you about circuits, you know what you know what whistle bridge, you know what filters, you know all the other circuits. If I were to ask you about what is behind the display and processing, you know behind it is microplane, micro C. As of tonight, we were talking about A to D. All right. So I think you get your mind right. Where are we progressing from the first day until now? All right. I mean the way you all study, the way you understand this thing is very much depending on, it's up to your style. You may, create your own notes, or you can basically just based on these slides. All right. So this is basically the simple architecture. This is basically the other architecture that you may have not seen previously. As I mentioned, we always talk about one sensor, one signal conditioner, one A2D, and one display. One system just connected to one sensor, reading one input, and display one reading. For example, if I were to read temperature of this room, so I have only one sensor, and I have one display at the end. All right. This is the very basic for learning. But in the real scenario, in the real case, you are looking at this. You are looking at this, and you are looking at this. Is the reality of system of instrumentation and data acquisition. All right. The main important part that you must take note here is multiple number of inputs. All right. Previously, we just working on one input. Now we have many. All right. And to be able to do that, you have some kind of multiplexer. Okay. You can see from this part, multiplexer's job basically is to switch between inputs that basically channel to the amplifier. Okay, you can have one amplifier, or in the system you may have amplifier. Okay, one input, one sensor, one amplifier, one sensor, one amplifier. In this architecture, you may have one amplifier for all sensors, while in the middle you have the multiplexer. So multiplexer's job is basically to act as a switch, I would say. Okay, this guy maybe having some kind of switch. So multiplexer's job is basically to connect to the switch. Okay, to connect to maybe the first switch, the second switch, third switch, fourth switch, or fifth switch. All right, so this is the job of multiplexer. Okay, the first, second, third, second, fourth, second, fifth, second, they will basically switching and go back in circle. So when the switch is basically connected to this input, will be going into the amplifier. Okay, when the next stage, the switch will connect to this guy, and the input for this guy will be coming in, and the rest of the inputs are not connected. So this is the job of multiplier. Multiplexer comes in speed, okay, in terms of hertz. So depending on what kind of acquisition that you are working on, you have to look at the speed of the multiplexer. If I want to take a reading of 100,000 per second, you will have to find multiplex that which can support the kilohertz. All right, so that's really the job of multiplexer here. Do you have question, guys? No?
Yes, doctor.
Yes, please.
So, doctor, how can you relate this whole system with the car system, like the brain box and the various sensors in the car?
Again, who's asking
Can you
question
hear me,
just now?
can you hear me, doctor? Maybe network.
Can you now?
Can you hear me, doctor?
Yes.
I say, how can we relate this whole system with
Okay.
the brain box, maybe in the car system? maybe because there are various sensors in the car and the brain box. So how can we relate all whole system with the reality in the car, for example? Maybe I have network problem here.
On. Can you hear me, guys?
Yes, we can hear you, Doctor.
Well, the question basically. So to relate that to relate the system that this sensor, you know, this is maybe coming from the okay. So this one is coming from I hope you can follow me here. This one is coming from red. Okay. Okay. So for a coolant sensor, you know, it's a kind of resistive transducer. So you may need some kind of Wheatstone bridge here. Okay? And from here, acquisition board to read from the sensors. All right. For example, here you have sensor. The second one you have airbag sensor, and for airbag sensor you may have switch or on off system, which is very simple. So they need another kind of signal conditioner. And for the last one, for the third sensor, is basically the ranger is some kind of inductive or capacitive sensor. So you may need Wheatstone bridge or Wheatstone bridge or simple switch system. All right. So this is computer board in a car. Okay, which basically works on the reading the sensor. Okay, so the information flow is from left to right. Okay, this is from the sensor going into the system. Okay, so from here, basically, for a coolant sensor, the computer will come out with a temperature gauge. All right, you may have seen and all that. Right? Yeah, something like this. Okay, so for airbag sensor, they will give you, you know, this for the airbag symbol and all that. If the sensors is engaged, you may have this symbol here on the dash and the range. As simple as this. Abdullah, did you get my explanation?
Doctor, I'm getting, yes.
It's all good. Everybody, everything's okay. Because I get a little bit of the. I am.
Maybe the network is creating.
Abdullah, can you use the chat box there, Abdullah? Can you use the chat box? Yeah.
Oh, okay.
Can you type in there so that I can read, because I barely hear what you are talking basically. Is a lot of delay here. Orang lain macam mana? Jelas ke? Putus-putus ke?
Clear, Doctor.
Clear, thank you. All right. So the question requested by Abdullah here, I think I already did try to answer that. So now we are looking at the ADC. All right. Also, if you still remember the box that I have, yes, thank you, Abdullahi. If you get the box that I have mentioned, 1, 2, 3, 4 box, this is box number 3. Okay, this is box number 3D, and for any kind of A to D, you are receiving analog and you have to produce some kind of digital signal. All right, that's the job of A to D. You are receiving this is in terms of voltage. It can be 10 volts, can be 5 volts over here, and when you get converted into digital, you are talking about 0 and 1. It should be 0 and 1. All right, this is basically the transition that they are showing. Okay. So when you talk about A to D, first you have to understand that the input signal is any kind of analog signal. And here you need to understand about the sampling rate. All right, sampling rate, that is some information data that you receive. All right, if for example in some experiment I need to do data collection 100 sample per second. All right, meaning that in 1 second I want to collect 100 samples, so I will do sampling 100 times. For example, if I a second, so my sampling rate is 1 hertz. If I sample sampling at 2 hertz, if I am collecting 10 samples a second, my sampling rate is 10 hertz. All right, so you have to understand this. All right, very important. Yeah, it shows how much sample you can basically provide in a period of time. All right. Input signal, of course, all are in analog. For example, also good for you that for any kind of input signal, it's some I am detecting kind of delay actually, guys. Delay actually. Kita disconnect sekejap you disconnect back, you come back. Can we do that?
Okay, Doctor.
Okay, guys, I nak tukar internet line actually. It's not very good. Kita break sekejap